excited to be with you today, and I'm going to talk about the worlds of creation, the solar system, basically, because they are creations. The objects, the moons and planets of our solar system are creations of God, and that's something that's counter to the narrative that we hear that the universe is an accident, and the planets are an accident, and so on. But that's not what the Bible teaches. And so I think it's helpful for Christians to know some of the basics about our solar system. And we live in an amazing age where we've sent unmanned spacecraft to past all the large worlds of our solar system, all the planets and a number of the moons and other objects. We recently sent people around the moon again, and that was very exciting. The Artemis mission. I was glued to the TV watching that. Just amazing. And we've learned so much and so much more to learn. And so I think the two things I want to accomplish this morning is hopefully give you a greater appreciation for the mind, the power, and the creativity of the Lord. And then secondly, to give you some talking points when you're discussing these things with unbelievers, because our solar system bears all evidence of being created by Almighty God and not an accident. It really does. So this is an overhead view of our solar system, the way it would look right now with the planets highlighted. They are tiny compared to the distances between them, not the way you see them in textbooks where they make them big so that you can see the planets. I understand why they do that, but it's really enormous. The solar system is. The distance to our sun, 93 million miles. That's something that is kind of mind-blowing to think about that. The farthest that human beings have traveled into space, we just set the record at 256,000 miles. So we're nowhere close to traveling to other planets or anything like that. This is the way the planets would look today if you could see them. It's neat that we can simulate that. But because God upholds his universe in a consistent way that is governed by mathematics, that we can discover, we can actually predict where the planets will be, and we can compute where they were in the past. It's pretty neat. You can't do that with everything. Certain things like weather, we can't know the initial conditions well enough to predict the weather more than 2 weeks in advance, and even then it's iffy, right? But with the planets, we can, and God is ruling his universe in that way for our benefit. That the planets orbit the sun in ellipses. Well, that the planets orbit the sun was discovered by Aristarchus. He was a Greek astronomer and mathematician living a few centuries before the time of Christ. His idea didn't catch on because most people didn't think that anything as big as the Earth could move, but it does. It rotates and it orbits the sun. It orbits the sun in a counterclockwise fashion if you're looking over the North Pole of the Earth and of the sun. That's kind of the way the planets move. And then the fact that planets orbit in ellipses rather than circles, you might notice with Mercury, it's closer to the sun there and it's farther there. That was discovered by Johannes Kepler. Johannes Kepler was a devout Christian and biblical creationist. He believed the same way that I do, that God created the universe in 6 days a few thousand years ago. He computed the age of the Earth, even using the genealogies, which I've done as well. So he discovered that the planets orbit in ellipses and that they speed up a little bit when they get closer to the sun. Because the planets' orbits are only slightly squashed, they're only slightly ellipses. They're pretty close to circles, but not quite. You can't often tell, but with Mercury, maybe a little bit. You can tell it speeds up when it's closer to the sun and then slows down when it's further away. And he discovered the exact mathematical formula for that. Pretty impressive. And he also discovered the relationship between a planet's period, how long it takes to orbit the sun, and its distance, how far away it is from the sun. There's a simple mathematical relationship between the two. The period in years compared to the distance in AUs, where an AU is the Earth's distance from the sun. It turns out the period squared equals the distance cubed. Exactly. Pretty neat. And you might say, well, I think I can see that the planets are orbit in not quite perfect circles, that Mercury's a little closer sometimes, a little farther away. I think I could have figured that out. Well, Kepler didn't have a computer simulation like this. He had a list of numbers recorded by Tycho Brahe, also a Christian, and they didn't even have telescopes back then. Tycho Brahe had built an instrument that allows you to sight down and measure the position of a star or planet with incredible accuracy before the invention of telescopes. Pretty amazing. And recorded a list of numbers of where planets like Mars are in the sky, in Earth's sky. So you need to understand we're on one of these things moving, looking at other things moving, and Kepler figured that out. It is. It is amazing. It is amazing. I hope you appreciate the brilliance of the man to be able to, because you have to solve two problems at once. You have to solve the Earth's motion and the other thing that you're looking at simultaneously. Not simple. I hope that gives you an appreciation for how brilliant some of these people were. And again, devout Christians. Pretty neat. So that's the inner planets of the solar system: Mercury, Venus, Earth, Mars. The outer planets orbit much further away. And because the period squared is proportional to the distance cubed, the outer planets barely move. I really have to speed up time to get them to move. So the inner planets, you can see them just whipping around there, and then you can finally get Jupiter to orbit the sun. It takes 12 years. Saturn takes 29 years to orbit the sun once, and so on. Pluto takes 248 years to orbit the sun once. It's still out there, by the way. It's just it got demoted. It's no longer considered a planet, but it's still there. And we'll look at it too. But this is just the 8 classical planets in the way they look. The planets all orbit in approximately the same plane. And we used to use that as a design argument. I think it still is, but the secularists have come up with an explanation for that too. They say that our solar system formed as a nebula collapsed in on itself, and so that's why everything, like a pancake, if you spin it, or a pizza, when you spin it, it tends to flatten out. They would say that's the reason, but you could also argue that it's a design feature, and I think it is. My point is, I don't use that argument one way or the other, because you can explain it either way. A lot of times you'll see the solar system from a tilted perspective like that, and sometimes they'll show it that way in textbooks. And people have the misconception that that's an overhead view and the orbits are really squashed. They're not. They're only slightly squashed. So that's what the solar system looks like. Now, we have sent probes to all the large planets of the solar system. We even have probes that are dedicated to looking at the sun, which is 99.98% the mass of the solar system. It's there. And so this is the greater light that the Lord made to rule the day. And one of the things that you learn from astronomy is that God really overdoes it, because God could have, to make a light to rule over the earth, God could have put a light bulb up above the earth. Instead, he made an object that's 100 times larger than the earth in diameter. If it were hollow, it could hold 1,000,000 earths. And just a little demonstration of God's unlimited power. So that's the sun. It is a ball of hydrogen gas, hydrogen and helium, held together by its own gravity. Yes, gas has gravity. If you have enough of it, it'll hold itself together in a spherical shape. So that's why the sun's spherical. Most things in the universe are, if they have enough mass anyway. So that's what it looks like. There are these little spots on the sun, which astronomers call sunspots, because we're not very creative, apparently. And those are cooler regions on the sun. The average temperature at the surface of the sun is 6,000 degrees Celsius, whereas sunspots are a chilly 4,000 degrees Celsius. So they're a little bit cooler, and they don't emit as much light. They're caused by magnetic fields that inhibit convection. And so that causes them to get a little bit starved from their power source. So that's the sun. And its power source is fusing hydrogen into helium. Very efficient power source. The sun theoretically has enough power to last billions of years. And secularists say, well, it has lasted billions of years. Well, no, it's not. It's a few thousand years old, like everything else God created. But God gave it enough mass that it wouldn't be an issue for a long time. Really interesting. And then, of course, God could regenerate it after that time anyway. It's not a problem for God. So there's the sun, the central mass of the solar system. All the planets that orbit the sun, we've sent spacecraft either past them or in orbit around them. Mercury, for example, we've sent 2 spacecraft past Mercury. There was the Mariner 10 spacecraft back in the 70s, and then the Messenger spacecraft more recently. There's what Mercury looks like. Quite a bit like the moon. It's got all these craters on its surface. It lacks the big dark maria that the moon has, but it does have a lot of craters. And it kind of reminds me of the passage that, when God initially made the earth, it was without form and void. It was empty, and it didn't have the form that it has today. Mercury is kind of like that, because God never bothered to form it or fill it. He did that only with the earth. Mercury's 3 days younger than the Earth. Earth's made on day 1. All the planets are made on day 4, along with the stars, everything else in the universe. Earth is very special. So that's what Mercury looks like. It's about 1/3 the size of the Earth. It has no substantial atmosphere, and so anything that comes nearby hits it, any rocks or anything, and that accounts for all those craters. And God may have used process when he made Mercury on day 4 of the creation week. He might have made the material previously on day 1 maybe, and then brought it together and made the planet on day 4. We don't know for sure. The Bible doesn't give us details, but that's a possibility. And because Mercury orbits 3 times closer to the sun than Earth does, that day side gets baked. It has a surface temperature of 800 degrees Fahrenheit, whereas the night side drops to like negative 200 degrees because Mercury rotates very slowly. So the day side just gets baked. It sees the sun for many, many Earth days, and the night side hasn't seen the sun for many days, and so it cools off. There's no atmosphere to redistribute the heat or to trap it in. So Mercury is a planet of extremes. And since the day side is very hot and the night side is very cold, it follows that there is a place on Mercury somewhere around there where the temperature's kind of nice. So if you crash land on Mercury, you want to aim right about there, okay? And then the thing is, because Mercury is rotating so slowly, if you started running west, you could actually outrun sunrise. That's something to think about. And you need to do that because if you stick around and let the sun rise, then you get vaporized, right? Because the temperature rises to 800 degrees Fahrenheit. And that's rather uncomfortable. So there you go. So now you know what to do if you ever crash land on Mercury. One of the things that's interesting about Mercury is it has a strong magnetic field. And that was something that was a bit of a surprise to secular astronomers, because magnetic fields naturally decay with time. Magnetic fields are caused by electrical current in the core of a planet. Earth has one, Mercury has one. And that electrical current encounters resistance. It runs down with time, right? And so if Mercury were billions of years old, the magnetic field should be dead by now. And so it was quite a surprise to find it still has one. It's in the process of decay. There's evidence that between the flight of Mariner 10 in the 70s and the more recent Messenger mission that the magnetic field has decayed appreciably. And so that indicates that Mercury's thousands of years old. It's nowhere near billions, like the secularists believed. So there's the first planet from the sun, Mercury. The next planet out is Venus. It's been called Earth's sister planet because it's about the same size as the Earth, just slightly smaller. It's like 95% the size of the Earth. So there's Venus. It looks pretty bland if you've ever looked at it in a telescope. It does go through phases as we see it from Earth, like the moon does. And when it's in the crescent phase, it looks really big. And when it's in near the full phase like that, it's really small because it's orbiting the sun. And Galileo noticed that and realized that the planets must orbit the sun, not the Earth, as was previously believed. So there's what Venus looks like. Now, Venus rotates backwards, which is interesting. So the sun would rise in the west and set in the east. And I think God did it that way just to confuse the secularists, because that shouldn't be the case. If the solar system formed from a collapsing cloud, all the planets really should be spinning the same way due to a principle called conservation of angular momentum. Right? When the skater is spinning and she pulls her arms in, she spins even faster. She doesn't suddenly reverse direction. That would be ridiculous. There's a physics principle there. And yet Venus is going just exactly backwards from the way secularists would expect. That's a design feature. It just shows God's creativity in the way he made the solar system. Venus looks like that because it's permanently enshrouded in very thick clouds. And so you never see the surface of Venus. No one ever has, at least in visible wavelengths, because of those thick clouds. And secularists were free to speculate that Venus might have all kinds of exotic life forms on the surface because they believe in evolution. And if life's just an accident, it happened on Earth, probably happened elsewhere. The universe is probably full of life. They figured maybe tropical paradise on Venus with all kinds of exciting exotic life forms. That was before they realized the surface temperature of Venus is 900 degrees Fahrenheit. You're not going to have life on Venus. You can't even have liquid water at that point. Venus is even hotter than Mercury because that thick atmosphere, 100 times thicker than Earth's, and it traps in heat. And so you get an extreme greenhouse effect. And, the climate alarmists say, if we're not careful, that'll happen on Earth. It can't happen on Earth. Our atmosphere is only 1% Venus's atmosphere, so that's not possible. But in any case, it does happen on Venus because of that thick atmosphere of carbon dioxide, which is a mild greenhouse gas. But if you have 100 times the amount we have on Earth, that's pretty substantial. Those clouds are made up of sulfuric acid type compounds. So lots of ways to die on Venus. It is not a place you'd want to vacation. We now know what the surface looks like without those clouds because the Magellan spacecraft went into orbit around Venus and used radar. Radar can penetrate clouds. That's what the surface of Venus looks like. So that's a fairly recent image within the last couple decades that we've had that. And some of the newer textbooks will show you a picture of Venus like that. It doesn't look like that. That's a radar map. It shows you the elevation of different features. There's 2 supercontinents on Venus, or there would be if it had oceans, which it doesn't. But that's what Venus looks like, really a tortured planet and not a place to visit. But those sulfuric acid clouds make Venus highly reflective, and they make it to be beautiful. It's the 3rd brightest object in our sky. You get the sun, moon, and Venus. And you will see it in the west after sunset, super bright. That's Venus, and it's going to get higher and higher over the next couple months, and then it will sink back down again. Pretty neat that we can predict that kind of stuff. So that's the second rock from the sun, Venus. The next planet out, Earth, my very favorite, has the best restaurants of any planet. All your friends live there. All their friends live there. There's Earth. It's a beautiful planet. The bright spot there is a sun glint. It's a little brighter than it should be because we found if we adjusted the projector to make it look right, Earth became too dim. So that's our compromise. But really a stunningly beautiful planet. And I feel very privileged that we live in a time where we have seen our planet from space. And I don't know if you've seen any of the pictures from the Artemis missions, but it's beautiful. It's so beautiful. And it shows that God really has a sense of beauty, or rather we do, having been made in God's image. And so we can appreciate this beautiful world that's designed for life. Isaiah 45:18, God formed the earth to be inhabited. And so Earth has all the right features that make it right for life, such as ourselves, to live on its surface. And so Earth has the right kind of atmosphere. It's got free oxygen in the atmosphere that we need to breathe. It's got liquid water on its surface, and that's something that's rather important. All life that we know of requires liquid water because it's a good solvent. It's the sort of the universal solvent. Almost anything will dissolve in it. And of course, the Earth's 71% covered with water, the substance of life that we need for life, at least the life that God chose to create. Earth has plate tectonics. Other planets do have tectonics, but only Earth has plate tectonics where the continents can shift. And we think that's the mechanism God used to flood the Earth and also to end the flood. There's some neat models on that, like the one by John Baumgartner that explains how that happens. It's a good a computer simulation that shows how God may have initiated and ended the flood. So pretty amazing. Wonderful planet. Earth has a large moon. Mercury and Venus have no moons. Earth has a large moon, which we call the moon. That's because it was the only one that we knew of for 5,600 years, right? And it was Galileo who finally discovered that that other planets have moons as well. He found that Jupiter had moons, but let me speed time up a little bit. Here's the moon. Okay, now from Earth, we always see the moon like that because the moon does rotate, but it rotates at the same rate it revolves around the Earth. So we always see the same side. One of the neat things about the Artemis mission is they orbited around the moon. And so you'll see the near side has all these dark maria. The far side doesn't have as many. And so you'll see some of these pictures of Artemis. One prominent feature, there is this little maria down here that's Mare Orientalis, and the Artemis mission got a beautiful view of that. You can't see that from Earth, so that's kind of a proof that we did go out into space. It's not a conspiracy. So there you go. So there's what the moon looks like. The moon does rotate, but it rotates at the same rate it revolves around the Earth. That's called tidally locked. All large moons do that. And so there's the Earth in the background. And one of the real pretty images from Artemis showed as they orbited around the moon, it showed Earth set. It was really stunning. If you haven't had a chance to see that, you'll see that in the upcoming newsletter that we'll have on the 15th. So check that out. Beautiful. The moon has what's called remnant magnetism. And that's where it has little bits of magnetic field randomly oriented rather than a north and south field like the Earth has. And that's an indication that the moon can't be billions of years old because remnant magnetism, like all magnetism, decays with time. The moon is spiraling away from the Earth. And if you'll come back to the evening session, I'll show you how that is an indication that it can't be billions of years old. So there's a lot of indication that the universe is not only designed by God, but was designed when and how he says it was. Earth has a magnetic field that is decaying. We've been able to measure that for the last 130 years. And it's decaying in an exponential fashion, meaning that if you run the equation backward, the Earth's magnetic field would have been stronger than a neutron star in a hypothetical 60,000 years ago, which would be impossible. That'd rip the iron right out of your blood. So the magnetic field is an indication that Earth cannot be billions of years old. A lot of stuff like that. You tend to not hear about that in the secular school system or on the media or anything that's controlled by secularists because it's contrary to their narrative, but it's true. The next planet out is Mars. Now, although Venus has been called Earth's sister planet, Mars really is the most Earth-like planet. It's only half the size of the Earth, so the gravity would be quite a bit less, but it has a lot of Earth-like features like canyons. In fact, you'll see an enormous canyon right there. You see that? Looks like a big scratch mark. That's an enormous canyon called Valles Marineris. It's much bigger than Earth's Grand Canyon. In fact, that would span the entire United States of America. It's huge. It's not a water canyon. It's a tectonic fissure where the crust is broken apart, and it dwarfs our Grand Canyon. Mars has mountains on it. You can see 3 of them right there, and then a 4th one right there. The 4th one is called Olympus Mons. That is the largest known volcano, and it is a volcano. It's thought to be dormant, or it's thought to be extinct. It might just be dormant. It's 3 times taller than Mount Everest, and the base of it would cover the entire state of Iowa. It's huge. It's a shield volcano, very shallow sloping. So Mars has Earth-like features. It has a North Pole and a South Pole that are covered with ice, just like Earth's, although the ice on Mars is primarily frozen carbon dioxide, not water ice, so it's dry ice. And the polar caps shrink in the summer and expand in the winter like Earth's do. And so Mars has seasons like the Earth because it's tilted in its orbit around the sun. That's what causes seasons. So a lot of Earth-like features. There are dried riverbeds on Mars, meaning it once had water on its surface. It doesn't today. The atmosphere is too thin to support liquid water. Water would immediately evaporate. If you heat up ice on Mars, it immediately goes to vapor. There's no liquid state. It's kind of like dry ice on Earth. And that's because it has insufficient atmospheric pressure for water to exist. A lot of interesting features on Mars. Some of these you can see in a small telescope. Like, for example, Syrtis Major is this large feature right here, this large dark feature. It's called Syrtis Major. Below it is a big valley called Hellas. And I always look for those when I'm looking at Mars in my telescope, although 50% of the time they're on the other side, right? So you can't always see them. But wonderful planet, a lot of Earth-like features, but it's also different from Earth in many ways. It has a very thin atmosphere of carbon dioxide, not enough to generate any sufficient heat. So the surface temperature of Mars is very cold. It would be too cold really for human life to survive. You can't breathe on Mars. There's no liquid water. And now the rotation's similar. Mars has a 24-hour, 36-minute rotation. That's kind of neat because you could sleep in an extra half an hour every day and it would never catch up with you. I think that's neat. Mars has 2 moons and they're tiny. They're called Phobos and Deimos. The names mean fear and terror because Mars is the god of war, the Roman god of war. So fear and terror accompany war. There's Deimos. It surprises people that small moons are not round. Deimos is less than 10 miles across. And so it has insufficient gravity to pull it into a spherical shape. So small moons tend to have kind of a random shape, essentially a large boulder in space. I think it looks kind of like a potato. So there it is. There's Deimos. Phobos is the inner of the 2, and it is slightly larger than Deimos. It's about 10 miles across, which if you think about it, that'd be a nice hike. You could hike around that moon. That'd be a nice little adventure, wouldn't it? So there's Phobos. It orbits really close to Mars, and so Mars would look enormous in the night sky. That would be something to see, standing on Phobos and looking up and seeing Mars like that. That would be extraordinary. So really interesting. Mars has remnant magnetism like the moon does, which indicates it once had a magnetic field and indicates it cannot be billions of years old. A lot of stuff like that in the solar system. Now, these first 4 planets that we've looked at, Mercury, Venus, Earth, and Mars, are called terrestrial, meaning Earth-like, because they're solid. You could land on them, walk around a little bit. Of course, with Venus, you wouldn't want to do that, but With the other ones, theoretically, you could. The outer planets are very different. The outer planets are made, Jupiter and Saturn, for example, are made of gas, and they're held together by their own gravity. Again, gas does have gravity. So you can't land on Jupiter. There's nothing solid to land on. It's a ball of gas, probably becomes compressed to liquid at some point. There's good evidence of that. So let's have a look at Jupiter. It's the largest planet in our solar system. It's about 10 times the diameter of the Earth. It's fun to look at in a small telescope. In fact, it's that star, that really bright star that you're seeing overhead at night, that's Jupiter. And you point your telescope at it, you'll see the stripes on it. Those are called belts and zones. The belts are dark orange features. The zones are light, kind of whitish. Those are clouds that get stretched around Jupiter. You know how Earth has jet streams? And we've got sort of three of them. We've got a polar one, a mid-latitude, and then an equatorial, and they go opposite directions. Jupiter's a bigger planet, so it has more jet streams than Earth has. So they rotate in opposite directions. And because its atmosphere is not transparent, it's got all these clouds in it, you can see visibly those jet streams. That's what the belts and zones are. Jupiter has an enormous red spot in the southern hemisphere right there, which astronomers call the Great Red Spot. Okay, and that is an enormous anticyclone, kind of like a hurricane, but it's a high pressure system, whereas hurricanes are low pressure. It's a storm on Jupiter. It's enormous. You could fit 2 Earths right in that storm. It's massive. And it's been in existence for at least 300 years. Since we've had telescopes powerful enough to see it, it's been there. It moves left and right a little bit. It can't go up and down because it's sandwiched between the lower equatorial belt and then the zone below that. So it can't go up and down, but it does move left and right. And you can, there's websites where they can predict about a month in advance where the red spot will be. And if you want to see it, the best time to see it is when it's kind of dead center, when it's right along the meridian of Jupiter. I mean, it's never center because it's below center, but when it's as centered as it can be. When it's near the edge, it's hard to see in a small telescope. So there's the Great Red Spot. You'll also see a little black spot up there. That's that's the shadow of one of Jupiter's moons. Jupiter has a number of moons. 4 of them are large, and they will, when they cross in front of Jupiter, they cast their shadow on it. And I've seen that. It's neat to see. Galileo was the first person to notice that Jupiter had moons, and that was a big surprise to him. That was in 1610. The telescope had just been invented in 1608 by Hans Lippershey. Galileo heard that it had been done, and he experimented and built his own. You couldn't go to Walmart and buy one back then. By the way, don't buy a telescope at Walmart, just saying. But he had to invent his own. And when he pointed it at Jupiter, he was surprised to see initially 3 little stars in a straight line next to Jupiter. He thought, that's odd that they're in a straight line. And then when he came back the next night, he found that they'd followed Jupiter because Jupiter moves relative to the background stars. And they were sticking with Jupiter and orbiting around it. And eventually a 4th one popped in, and he realized that Jupiter had 4 moons. He called them planets initially because nobody thought of other moons. There was just the moon. And that was proof that not everything orbits the Earth. He could see that these were orbiting another planet. So there's a shadow of another one of the moons there on Jupiter. Now, Jupiter has a number of indicators that it can't be billions of years old. For one, it has internal heat, which means it's radiating more heat into space than it gets from the sun. It gets 1 unit, gives away 2. And it can't do that forever because it would run out of heat, right? It's kind of like you take a potato out of the microwave. It's nice and warm. You can feel the heat coming off of it. Come back 2 hours later, it's cold. Well, Jupiter's a much bigger potato, so it can do that for thousands of years and still radiate heat. But if it were billions of years old, it too would be cold. But it's not. It's still radiating heat into space. And Jupiter has a powerful magnetic field, very powerful. In fact, you can get northern lights on Jupiter, aurora borealis, and southern lights on Jupiter. We've seen those. And that's because of that strong magnetic field that Jupiter has. You might see Jupiter has a faint ring system. That was a little bit of a surprise. We thought that only Saturn had rings until one of the Voyager spacecraft flew past past Jupiter, turned around, and could see the reflection of sunlight off a very thin ring system. Pretty neat. And those are just little particles of dust orbiting around Jupiter. Let's take a look at some of the moons real quick. Jupiter has 4 big moons. The innermost is called Io, or Io. And I love Io because it's so strange. It just looks like an orange that you forgot you left in the refrigerator, and you're like, oh dear. Yeah. And that's because it has volcanoes that are constantly going off. It's going behind Jupiter there. That was a little eclipse. But it has all these volcanoes. Those are the little spots that you're seeing there. There's volcanoes that are constantly going off. When Voyager 2 flew past Io in the, I think around 1980, it discovered 9 volcanoes going off at the same time. And Io is the most volcanically active world in the solar system, and it's completely resurfaced itself in its 6,000-year history. So that's why there are no impact craters that we know of on Io. It's just volcanic craters. So pretty amazing. Beautiful little moon, about the same size as Earth's moon. The next one out is Europa. It's just a little bit smaller than Earth's moon. And it's kind of a white moon with these large scratch marks on the surface that you see there, like a big cosmic cat came and just kind of swiped it. So it's interesting. We think those are caused by geysers that are erupting and causing those scratch marks, geysers of liquid water that then fall back to Europa. We're not sure about that, but that's the leading theory, and that would indicate that Europa has internal heat, which means it can't be billions of years old. The next moon out is Ganymede. It's the largest of Jupiter's moons. In fact, it's the largest moon in the solar system. It's actually bigger than the planet Mercury. But because it orbits Jupiter, it's a moon, not a planet. If we could separate it from Jupiter, it would be classified as a planet. So there's Ganymede. Beautiful little moon. I like the tricolor, kind of a dark brown and a lighter brown and then a bright white. Very, very beautiful. Makes me feel like we kind of got ripped off on our moon because our moon is very gray. But some of these other moons have delightful color to them. And then the outermost of Jupiter's big moons is Callisto. And it's got this interesting pockmarked surface with these little white craters all over it. So quite lovely. So those are Jupiter's moons, the 4 big ones. But Jupiter does have more moons than that. It's just those are the 4 big ones. If we go out a bit further, you'll find that Jupiter, the inner moon, there's 4 that orbit even closer to Jupiter, and they're very small. And all those moons orbit in the same direction, and they're all in the same plane. And that's a design feature. It's to avoid collisions because there's not a lot of space available. But when you get farther away from Jupiter, you'll find it has lots and lots of moons. I forget the latest number, but it's close to 100. Yeah. And they do not orbit in the same plane or even in the same direction. Some of them orbit Jupiter backwards. A lot of them orbit backwards. Some of those could be captured asteroids rather than original moons. Some of them orbit forwards and not in the same plane. If I rotate it sideways, you can see they all have their, it looks very messy, but each moon has a perfectly good orbit. It's just they all overlap in different directions. So, and that's a design feature because there's plenty of space available far away from Jupiter, so you don't have to worry about collisions. So there's Jupiter. Next one out is Saturn, everybody's favorite to see in a telescope, and it is worth it to see it in a telescope. So there's Saturn because that beautiful ring system, absolutely stunning. And the rings are beautiful. They really are neat to see. The rings are trillions of tiny little moonlets, rocks and pebbles and dust orbiting around Saturn. And lovely. And it's nice that the Lord tilted that planet, which is a design feature, because if the solar system had again formed from a collapsing cloud, all the planets ought to be upright. They shouldn't be tilted, but most of them are tilted. Jupiter's the exception. It's only slight tilt. The other ones are tilted. If God hadn't tilted Saturn, you wouldn't know that the rings are there because they're very thin. Although they're hundreds of thousands of miles wide, they're only maybe a mile thick. And when they're edge on, you can't see them. Now, Saturn does appear edge on twice in its orbit because if you think about it, it's tilted. Here's the sun, and we're orbiting around the sun, and Saturn's tilted like that. Eventually, they would go edge on, wouldn't they? And we just had that happen just last year. So they're going to be kind of thin for the next couple years. There's a famous picture of Saturn in a crescent phase, and I don't think people realize the significance of that. You can't see that from Earth. It's proof that we have indeed sent spacecraft past Saturn, the Voyagers and the Pioneers spacecraft. So we've sent 5 spacecraft out to Saturn, along with Cassini being the last. So really lovely planet. Saturn has a magnetic field comparable to Jupiter, not quite as big as Jupiter's, and that's an indication that it cannot be billions of years old. There's Saturn. It has hundreds of moons. I think I don't remember what the latest count is. They keep discovering more. Most of them are tiny. It's got a few big ones, like Titan. Let's do Titan real quick. Titan's the second biggest moon, orbiting the second biggest planet, kind of fitting. There's Titan. It's orange. It's the only orange moon, and the only moon that has a thick atmosphere of hydrocarbons and tholins. And hydrocarbons are things like gasoline. So gasoline would be really cheap on Titan because it's kind of made of it. On the other hand, oxygen would be expensive, so count your blessings. We know what the surface looks like due to radar. There's the surface of Titan. So pretty neat. And Titan has a lot of methane in its atmosphere, and that was really surprising for the secularists because methane is destroyed by ultraviolet light from the sun over time. And so if Titan were billions of years old, the methane should be gone. But it's not. It's still there because it's not billions of years old. It's thousands of years old. A lot of stuff like that that you don't tend to hear about in the secular media or in the textbooks that are written by secularists. Now, in the 1980s, a wonderful thing happened. The planets, the outer planets, Jupiter, Saturn, Uranus, and Neptune, lined up in this beautiful arc. And that allowed us to send one spacecraft past all of them, using the gravity of one to bend the orbit and speed it up and send it to the next one, slingshot it to the next one. So Voyager 2 went past Jupiter, Saturn, Uranus, and Neptune. It went past Uranus in the year 1986. And I remember when that happened, and it was very exciting. We got to see Uranus for the first time, and it was almost completely featureless on the days when Voyager 2 flew past. Now, Uranus is tilted on its side, which again would not be the case if the solar system collapsed from a cloud. So that is a design feature. And the moons that orbit Uranus, the inner moons, they all orbit on their side as well. They follow suit. So there's the planet Uranus. It has a strong magnetic field that was predicted by Russ Humphreys, a friend of mine who's a physicist and a biblical creationist, based on its age of 6,000 years. A number of interesting moons like Little Miranda that orbits around Uranus. So really a fascinating planet. It does have rings. They're quite thin, but they were discovered on Earth before they were, visualized by Voyager 2. So there's Uranus. Uranus has a twin brother called Neptune, almost the same size as Uranus. And Voyager 2 went past it a few years later. It was 1989 when Voyager flew past Neptune. And we discovered that Jupiter is not the only planet with a great dark spot on it. Neptune has one as well. It's not red like on Jupiter, but it's the same kind of thing. It's a cyclone. Yeah, in this case, a low pressure system. So really interesting. And a number of interesting moons, but we don't have time for all of those because I want to make sure we get to Pluto, because Pluto was a delight. When I was a kid, it was a planet, and it got demoted in 2005 or 2006, I think, because it's very small, smaller than we first thought. When it was first discovered, we thought maybe Pluto was as big as Earth, and then they realized, no, it's maybe as big as Mars, and then no, it's actually smaller than Mercury. We now know that Pluto is only 2/3 the size of Earth's moon. It's itty bitty. And there are other objects out there orbiting at about the same distance as Pluto. And one of them we thought was bigger, Eris. We now know it's a little smaller, but with all these other objects, do we add them in as planets as well? Think of the children. They don't want to memorize 30 planets, right? It's bad enough they have to memorize 9 or 8. So we ended up kicking out Pluto and saying we'll classify it as a dwarf planet along with a few others of these objects that are out there. It wasn't until 2015 that we finally got a spacecraft past Pluto, and it was well worth the wait. This is what Pluto looks like close up. Yeah, the New Horizons spacecraft flew past Pluto in 2015 in July, and what a delight. And what a surprise for the secularists who were expecting that this dead world orbiting 40 times farther away than Earth does, and yet it's they would expect it would just be completely covered with craters because it's small, it can't maintain internal heat, and that far away from the sun, it doesn't get much energy, so there shouldn't be any geology on Pluto. It should just be covered with craters. And so they were very surprised to find there's a section of Pluto right here called Sputnik Planitia that has no craters. There's not a single crater there. And it indicates it's not billions of years old. It's recent. It indicates geological activity. There's mountains on Pluto, as big as the Rocky Mountains, some of them. You can see some of those here. Look like little bumps, but remember, we're looking at a dwarf planet here. So these are massive mountains, as big as the Rockies. Canyons, look at that canyon there on Pluto. Really delightful. And that's an indication that it's nowhere near billions of years old. That's something that was very shocking to the secularists. Pluto has 5 moons. Only one of them is big, and it's Charon, and it's about half the size of Pluto. And it also has mountains and valleys, canyons, some craters, but a surprising lack of craters if it were really billions of years old. And so that was a surprise to the secularists, but not to those of us who believe that God created a few thousand years ago, as the Bible teaches. That's something we'll talk about in the main sermon and why that matters. So just an overview of the solar system. There's a lot more we could talk about, comets and asteroids, and the Lord is full of creativity and just has a unique way of doing things that we wouldn't expect. But it also reminds us of the special beauty of this world where God himself walked and paid for our sins. I mean, God came to the earth. Of all these planets, it was Earth that God came to and walked and paid for our sins. Really, and if you think about it, most of the Bible takes place right around here, just in that little area of Earth. Most of it does. There's Egypt, there's Israel. There's a few mentions of other locations, but that's mainly it. Really gives a perspective on things, doesn't it? That God has his eye on this planet because he cares about you. The God who made all of that. And we're just one solar system. We've now discovered over 5,000 planets orbiting other stars. You could imagine 100 years from now when the technology is advanced and we know as much about one of these other solar systems as we do about our own today. You could imagine somebody picking one of these other 5,000 systems and doing a presentation like this that exhibits God's glory in these other systems. What a mind the Lord has. I hope that gives you a little taste of the Lord's power and a greater appreciation for the Lord that we serve. We do have some wonderful resources that I encourage you to check out. This presentation, I never do it exactly the same way twice because I don't have any notes up here. I'm just going through the solar system and pontificating. I hope that was interesting. But we do have that on DVD, and so you can check that out. That's a fun one. Tonight I'll be talking about this topic, Astronomy Reveals Creation. And this is kind of an older version of it, but I'll update it a little bit tonight with some of the new James Webb Space Telescope discoveries. So you'll want to come out for that. But if you can't, you can get it on DVD. The book that goes along with a lot of what I talked about and what I will talk about tonight is Taking Back Astronomy, showing you how the universe declares God's glory, not billions of years, not a big bang. Stargazer's Guide to the Night Sky, how to better enjoy the night sky from a Christian perspective. That's a fun resource if you want to know, well, which one is Jupiter anyway? And that'll help you with that. Constellations, when's the next meteor shower, stuff like that. When's the next eclipse? If you want to get a telescope, what kind you might want to get and how to use it, it's all in there. Even if you don't get a telescope, there's a lot of stuff you can see with naked eye or with binoculars. You can see Saturn's rings with binoculars. You just got to know which one's Saturn. So that's where the book's going to help you. The importance of Genesis is what I'll be talking about in the main sermon. We have a book on that. And so check that out. Really important. A lot of people don't realize how important this topic is. If you want a bulletproof argument for biblical creation, here it is, the ultimate proof of creation. Very different from the kind of argument people think they should make. A lot of people think you need to know a lot about science to defend creation. You really don't. You just need to know how to think. Learn how to think and debate the way that Jesus did in his earthly ministry. And that's what this book is going to train you to do. Very effective resource. I've been able to teach these techniques to teenagers within a week, and they've got it. By the end of the week, they can defend their faith. So it's not difficult. We have that on DVD as well. For those of you that say, I don't have time to read a book, well, I get it. We have it on DVD as well. Keeping Faith in an Age of Reason answers over 400 alleged Bible contradictions. You've heard the critics say you can't trust the Bible because this verse contradicts that one. I checked, it doesn't. And I wrote a book responding to over 400 of those. So if you've heard of alleged contradiction, the answer is probably in there. Introduction to Logic, how to use your mind rightly into the glory of God. That's a lost skill. Most people have never had a class in logic. What's the point of education? How to think properly. What's logic? How to think properly. What's the one class that's not taught in most public education? Logic. Interesting. And this is done from a uniquely Christian perspective, showing you that to think logically is to think biblically, to think in a way that's consistent with God's character. And that is a neat resource. I really wrote it thinking of homeschoolers, but a lot of adults have never had a class on logic. But in any case, I wrote a teacher guide as well with tests and quizzes. You can test your logical skills. And I went through that book with my home church in a series of Sunday school classes. So these are 10 Sunday school classes on logic for our audio visual learners. The Secret Code of Creation, I'll be talking about that this evening. If you can't make it, we do have it on DVD and also on Blu-ray, showing that God has built incredible beauty into an aspect of creation most people have never even thought about, and there's no secular explanation for it. We have a book on that as well. You might leaf through that book. Every picture you see there was not drawn by human hands. It's artwork of God. It really is magnificent. And check us out on the web as well, biblicalscienceinstitute.com. So thank you very much. God bless.